world where nobody knew that much about physics and there was only one crappy science student to do the job of teaching it to people. Hey, I'm Alyssa Wilson. You probably are in class with me. This is my garage. I'm bad at videos and I'm gonna tell you about Newton and his laws and other physics things. Yes, definitely. To start this project off correctly, I believe we should talk about the main man himself, Isaac Newton. His first law dictates that once something is in motion, it won't stop doing so unless it's acted on by an unbalanced force. An unbalanced force is a thing or person or really anything that acts upon one's acceleration. Acceleration is basically whether you're going faster, you're slowing down, or you're turning. Any fluctuation in speed is automatically acceleration, and those are the terms that you need to know for now. Potential energy is when an object could move but isn't moving currently because there's nothing acting on it, such as an unbalanced force. My finger would be that unbalanced force, and if it were to act upon it, correctly, it would do that. When it's moving, kinetic energy is the force exerted upon an object while it's moving. This could be seen as, say, a train sliding along the tracks, or, as demonstrated previously, a ball moving because of my finger, an unbalanced force. An unbalanced force is something that acts upon an object, such as that ball, to make it go forward, or backwards, or turn. Speaking of that, there is acceleration. Acceleration is when something either speeds up, slows down, or changes direction. Basically, if it changes speed in any way, shape, or form, it would be accelerating. Gravity is a force that pulls two objects in space together. Anything with mass also has gravity, and that means that anything in space is pulled towards another thing. The reason that we stand upright in Earth's gravity is because Earth's gravity is stronger than ours, therefore pulling it to us instead of the other way around. Air resistance is kind of self-explanatory. It's something's resistance to the way the air is currently going. Like, for instance, if you throw a ball but the wind is going this way, the ball is going to have air resistance, but if the ball doesn't have enough mass, it's not going to be able to do that, and it'll fly right back to where it was, therefore being carried by the wind. Friction is the phenomena that objects experience when being slowed down or rubbing against another thing. Friction is why we don't slide when we walk, because there's enough friction on the ground to keep us still. Things that give friction are usually things like rocks or other unbalanced forces that'll eventually lead you to a stop. There are three different kinds of friction, or there can be three different kinds of friction: rolling, sliding, and fluid. Fluid friction describes the relationship between a solid mass and a liquid, and how that would stay afloat. For instance, swimming would be an example of liquid friction, as well as a boat on water. That would be an example as well. Sliding friction is the resistance that an object experiences when it's being pushed against another, like this. It experiences this because there's friction or things that provide friction on both sides as they're rubbing together, slowly but surely stopping them. Rolling friction is the friction conveyed when something is rolling over a surface. Because there's still, friction, even though it's round and can go for a really long time, it does eventually stop, and that is called rolling friction. Centripetal force describes an object moving around in a circle on a fixed point. Like, for instance, when someone swings a yo-yo in a circular pattern, it's centripetal because where your hand is where the yo-yo is going around, and the string can only go so far. Fall occurs when the only thing acting on an object is gravity, because all of the other factors are completely elsewhere. Like, for instance, if you hold a hairdryer underneath a ping pong ball, it'll float up, but it'll come back down and, go up again because of air, or at least the force of the air. What's acting on it when it goes down is free fall. If something is accelerating in a straight line, it's going to want to keep doing that. That's why inertia, the tendency to want to keep doing that instead of turning, like, say, you would be doing, is a thing. That's a thing you know now. Momentum is defined as the speed that you're going at any current time. Like, for instance, momentum compared to speed, they're very different things. Speed is how fast you're going, like, overall, and momentum is how fast you're going at any given time. Newton's second law was FMA. Okay, it's not FMA, it's force equals mass times acceleration, also pronounced as FMA. And, it equals force. You can rearrange that in any way, shape, or form to get either force, mass, or acceleration, and there are other math problems, I'm sure, but that was not in the required list. Newton's third law states that for every action, there is an equal and opposite reaction. Like, for instance, when you pull on a rope and then you let it go, the rope sometimes goes the other way because it was stretched out that far. This happens when you bounce a ball, too, and it comes back up. That's the end! I'm done! Oh my god! Yes, I can move on with my life. Thank you and goodbye. Bloopers. What goes up must come down eventually, right? I think that had to do with Isaac Newton. Ice cream.